My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed second semester subject content and pedagogy of mathematics education at secondary stage as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: define mathematics laboratory. Mathematics laboratory, simple definition and example. A mathematics laboratory is a special room in a school where students can learn maths by doing activities and experiments. It is like a small lab filled with mathematical tools, models, charts, measuring instruments, puzzles, and games that make learning maths fun and practical. Instead of just solving sums on paper, students can see, touch, and try things to understand concepts better. Example: to understand fractions, a teacher can use fractional discs or paper cutouts. Students can join or separate pieces to see how fractions work. Importance: makes maths interesting and easy to understand. Encourages hands-on learning and curiosity. Helps students who struggle with only textbook learning. Builds confidence and problem-solving skills. Easy tip to remember: Maths lab is equal to learn by doing. Models, games, and activities make maths fun. Next important short question is: 2. Physical and digital forms. Physical and digital learning resources in mathematics. Mathematics can be taught using physical, tangible, and digital, technology-based resources. Both make maths easier to understand and more interesting for students. Physical resources. These are real, touchable objects used in classrooms, like geometric solids, abacus, measuring tapes, charts, graphs, fraction kits, puzzles, and flashcards. Example: using a 3D cube model helps students understand volume and surface area better than pictures in a book. Digital resources. These use technology, such as online videos, math apps, virtual labs, AR/VR simulations, smart boards, and games. Example: a geometry app can show rotating 3D shapes, making it easy to learn about edges and vertices. Why use both? Physical tools give hands-on experience. Digital tools give visual clarity and interactive learning. Tip to remember: touch and see, physical, plus click and learn, digital, is equal to fun maths learning. Next important short question is: 3. Worksheets, websites, animations, audios, videos, images, simulations, digital repository. Mathematics learning becomes fun and clear when we use different digital and print resources. Worksheets, practice sheets with sums, puzzles, and activities help students apply concepts. Example: a worksheet on fractions with coloring activities makes learning enjoyable. Websites, educational sites like Khan Academy or Insert portals provide lessons and quizzes. Animations and videos, short animated clips explain complex concepts visually. Example: animation showing how shapes rotate in space. Audios, math rhymes or podcasts make basic concepts easy for younger students. Images, charts, diagrams, and graphs give quick visual understanding. Simulations, interactive tools that allow students to experiment virtually. Example: a simulation to explore probability by rolling virtual dice. Digital repository. Online libraries that store question banks, lesson plans, and ebooks for teachers and students. Tip to remember: see, hear, do, and explore. These tools make maths simple and exciting. Next important short question is: 4. Write a note on mathematics clubs. Mathematics clubs. A mathematics club is a fun group activity in schools where students explore maths beyond the classroom. It helps students see maths as an interesting and useful subject, not just numbers and formulas. Purpose. Math clubs develop problem-solving skills, teamwork, and creativity. Students get opportunities to learn in a playful, stress-free way. Activities. Organizing math quizzes, puzzles, and games. Making math models like pyramids or prisms. Celebrating Pi Day and conducting exhibitions. Inviting experts to talk about real-life maths. Example. A club can arrange a math treasure hunt, where clues involve solving sums, making learning exciting. Benefits. Builds confidence and logical thinking. Encourages students who love maths to explore more. Helps weaker students enjoy learning through activities. Easy tip to remember. Math club is equal to fun plus friends plus facts. It makes maths practical, creative, and enjoyable for every student. Next important short question is: 5 Mathematics Knowledge Repositories. Mathematics Knowledge Repositories. A mathematics knowledge repository is a digital or physical storehouse of all kinds of maths learning materials. It is like a library of maths resources that teachers and students can use anytime to learn, revise, or explore new ideas. What it contains: ebooks, lesson plans, question banks, and past papers. Math puzzles, models, and activities. Videos, animations, and simulations for visual learning. Research papers and articles for advanced learners. Examples. Insert ePathshala for free textbooks and resources. Khan Academy for step-by-step math tutorials. NROER, National Repository of Open Educational Resources. For free digital content. Importance. Saves time by keeping all resources in one place. Makes maths easy to access for teachers and students. Encourages self-learning and curiosity. Tip to remember. Math repository is equal to one-stop shop for maths knowledge. It helps students learn anytime, anywhere with ease. Next Unit 7. Long questions. First important long question is: 1. Explain the role of mathematics textbook as a learning resource, connecting textbook with real-life examples. Role of mathematics textbook as a learning resource. A mathematics textbook is one of the most important learning tools in schools. It provides a clear structure for teaching and learning, helping both teachers and students know what to study and how to study it. The textbook presents concepts in a step-by-step manner, starting from simple topics and gradually moving to more complex ones. It also includes solved examples, exercises, diagrams, and activities that help students practice and understand better. As a teacher's guide. Teachers use the textbook to plan lessons, prepare activities, and ensure they cover all topics in the syllabus. It also gives teachers a sequence to follow so that students can learn in an organized way. As a student's friend. Students use textbooks for self-study, revision, and homework. They can refer to solved examples before solving exercises, which builds confidence. Connection to real life. Mathematics textbooks often include real-life problems. A problem on area and perimeter teaches students to calculate the size of their house or playground. Chapters on percentages relate to shopping discounts, GST, or bank interest. Problems on time and distance are useful for planning journeys. This makes learning meaningful because students see how maths is used daily. Importance. Textbooks provide consistency, so all students in a class learn the same topics. They introduce activities, puzzles, and projects that make maths fun. They encourage self-learning by giving clear explanations and practice questions. Tip to remember. Textbook is equal to roadmap for teachers plus companion for students. It connects maths with real-life situations, making learning easy and interesting. Next important long question is: 2. Discuss the importance and use of mathematics laboratory and virtual labs. Importance and use of mathematics laboratory and virtual labs. A mathematics laboratory is a special place in a school where students learn maths concepts by doing activities. Instead of only listening to teachers or reading textbooks, students use real objects like geometry tools, measuring instruments, models, puzzles, and games to explore maths. It makes learning fun and practical because students can see, touch, and experiment with mathematical ideas. Importance of Maths Lab. Builds clear understanding of concepts like shapes, fractions, or measurements. Develops logical thinking, problem solving, and creativity. Makes maths enjoyable through hands-on activities. Example. Using a cube model in a maths lab helps students easily understand volume and surface area instead of just memorizing formulas. A virtual mathematics lab is an online platform where students can experiment with maths concepts using simulations and software. It is like a digital maths lab on a computer or smartphone. Importance of virtual labs. Helps students visualize concepts in 3D like rotating solids or exploring graphs. Makes learning accessible anywhere, even at home. Encourages self-paced learning. Example. A virtual lab can show how changing the radius affects the area of a circle with live diagrams, making maths interactive. Why both are important? Maths lab gives hands-on, real-world experience. Virtual lab offers technology-based, interactive learning. Together, they make maths clear, exciting, and meaningful for all students. Easy tip to remember. Touch and try in Maths Lab, click and learn in Virtual Lab. Next important long question is: 3. How can digital resources like AR, VR, AI, OERs enhance learning in mathematics? Digital resources make mathematics more interactive, visual, and easy to understand. Tools like augmented reality, AR, virtual reality, VR, artificial intelligence, AI, and open educational resources, OERs, bring maths concepts to life and make learning interesting for students. Augmented reality, AR. AR adds digital images or 3D models to the real world through smartphones or tablets. Example, students can scan a picture of a triangle and see a 3D rotating pyramid, making geometry concepts clearer. Virtual reality, VR. VR creates a fully virtual environment where students can explore maths concepts. Example, students can enter a virtual space to walk around 3D shapes, improving understanding of volume and dimensions. Artificial intelligence, AI. AI-based apps give personalized learning, track students' progress, and suggest questions based on their strengths and weaknesses. Example, AI math tutors like Bijus or Khan Academy give instant feedback and tips. Open educational resources, OERs. OERs are free online resources like videos, simulations, worksheets, and ebooks. Example, Inserts Diksha and Roar platforms provide free math lessons for all students. Benefits of using these tools. Makes abstract concepts visual and easy to understand. Encourages self-learning and curiosity. Helps students learn at their own pace, even at home. Improves engagement and reduces math fear. Easy tip to remember. AR shows it, VR takes you inside it, AI guides you, OERs share it for free. Digital resources turn maths from boring numbers into exciting experiences, helping students connect concepts with real life and technology. Next important long question is 4. Explain the role of community and pooling of resources in mathematics education. Role of community and pooling of resources in mathematics education. Community resources are the people, places, and materials available in the local environment that can help students learn mathematics in a practical and meaningful way. Pooling these resources means collecting and sharing them to make maths learning more effective, hands-on, and low-cost. Role of community resources. 1. Human resources, local teachers, parents, engineers, shopkeepers, and artisans can explain real-life maths applications. Example, a shopkeeper can show how to calculate discounts or profit and loss, connecting classroom lessons with daily life. 2. Local places and institutions, banks, markets, construction sites, and community centers provide real-world learning experiences. Example, visiting a construction site helps students understand measurement, geometry, and volume. 3. Natural resources, parks, rivers, and playgrounds can be used to teach shapes, measurements, or data collection. Example, students can measure tree heights or garden areas to practice formulas of area and perimeter. Pooling resources effectively. Schools can share maths kits, instruments, and charts among themselves. Teachers can organize field trips, workshops, and competitions using community help. Students can participate in real-life projects, like surveying their neighborhood for statistical data. Benefits. Makes maths practical and relevant to daily life. Encourages teamwork, problem-solving, and creativity. Reduces cost by using locally available materials. Builds students' curiosity and responsibility towards their community. Easy tip to remember. People, places, projects, and practice use community for effective maths learning. Summary. The community acts as a living classroom, helping students see maths in action. Pooling and using local resources make maths interactive, meaningful, and enjoyable, while connecting school learning with real-life experiences. Students not only understand concepts better, but also develop skills to solve practical problems. Next important long question is 5. Describe the process of developing self-learning materials, charts, models, games, toys, etc. Developing self-learning materials in mathematics. Self-learning materials are tools like charts, models, games, and toys that help students learn mathematics independently. They make learning hands-on, visual, and fun, and allow students to explore concepts at their own pace. Steps to develop self-learning materials. 1. Identify learning objectives. Decide what concept or skill the material should teach. Example, to teach fractions, the objective could be students should understand addition and subtraction of fractions. 2. Choose the material type. Decide whether it will be a chart, model, game, or toy based on the topic. Example, fraction circles or paper cutouts for fractions, dice for probability, or geometric solids for volume. 3. Design and plan. Sketch the material and plan how students will use it. Make it simple, colorful, and durable. Example, create a fraction pizza with removable slices for easy understanding. 4. Prepare the material. Use locally available items like cardboard, clay, paper, beads, or sticks to make models or charts. 5. Test and improve. Try the material with a few students, observe their understanding, and make improvements. Example, if students find it hard to separate fraction slices, adjust the size or labels. 6. Integrate into learning. Use these materials during classroom activities, group work, or individual practice to reinforce concepts. Benefits of self-learning materials. Encourages independent learning and exploration. Makes abstract concepts concrete and visual. Increases student interest and engagement. Develops problem-solving and critical thinking skills. Easy tip to remember. Plan, design, prepare, test, use is equal to effective self-learning materials. Summary. Developing self-learning materials involves planning, creating, and testing tools like charts, models, and games. These materials turn maths lessons into hands-on experiences, helping students understand concepts better while learning actively and independently.